Let's assign the formula charges for sulfate ion. We mean by the formula charge, this -2 we usually write on the top of the sulfate ion. First, the formula charge is equal to the number of valence electrons in neutral atom minus the unshared electrons plus half the shared electrons. Before we start, we need to know the valence electrons of both the sulfur and the oxygen. First, sulfur has 16 electrons, and those electrons are distributed, 2 of them in the first shell, 8 of them in the second shell, and 6 of them on the third shell. So it has 6 valence electrons. As for oxygen, it has 8 electrons, 2 of them in the first shell and 6 of them in the second shell, so it has also 6 valence electrons. Let's try to draw the sulfate ion. The sulfate ion has sulfur atom bonded to 2 oxygen, doubly bonded to 2 oxygens from both sides, and singly bonded to the other 2 oxygens. This is why we have SO4. Those are 4 oxygens. Now we need to count the surrounding electrons for sulfur. So sulfur has 6 valence electrons. If you count here, we have 1, 2, 3, 4, 5, 6. We have 6 surrounding valence electrons around sulfur. Now for this oxygen, we will count the valence electrons. We only have 2. So we have to draw the rest of the electrons as lone pairs. So I have 1 lone pair at the top and 1 at the bottom. This is a similar oxygen atom, so it has also 2 lone pairs. For this oxygen, if you count the electrons surrounding this oxygen, it is only 1 single electron that is participating in the bond between the oxygen and the sulfur. We have 2 electrons, 1 of them belongs to the oxygen, so we need another 6 electrons. So if we write down the electrons as lone pairs, so we have 1, 2, 3, 4, 5, 6. You can see that this is an odd number of lone pairs. This is why we have to add an extra electron to make it as lone pair. This extra added electron will make this oxygen carry a negative charge. Similar to that, this oxygen, we have also 3 lone pairs and a negative charge. Now let's calculate the formula charge for the sulfur. The sulfur has the 6 valence electrons, like we said here, minus all the unshared electrons. We have 0 unshared electrons surrounding sulfur, plus half the shared. Now if you count the shared electrons, each bond represents 2 electrons. So each bond is formed due to the participating of 2 electrons, one of them from the sulfur and the other from the oxygen. So if I count here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is surrounded by 12 shared electrons. Now if I cancel this with that, it will give me 6. So 6 minus 6 is equal to 0. Now let's assign the formula charge for the doubly bonded oxygens, and you have to remember we have to multiply the number by 2 because we have 2 atoms. So first I have to write down the 2, not to forget it. Then the number of valence electrons, I have 6 valence electrons, minus all the unshared electrons, I have 1, 2, 3, 4. I will apply it on this atom. So I have 1, 2, 3, 4, plus half the shared electrons. If I count the shared electrons, I have 1, 2, 3, 4, 4 shared electrons. I will cancel the 2 with the 4, so I have here 2. 2 plus 4 is equal to 6. 6 minus 6 is equal to 0, so 2 multiplied by 0 is equal to 0. So the formula charge on those 2 oxygens is equal to 0. Now we need to calculate the formula charge on the singly bonded oxygens. I will calculate it in this oxygen. Then I will multiply it by 2 because those are 2 identical atoms. So I multiply by 2. Then I have 6 valence electrons minus, and I have 1, 2, 3, 4, 5, 6. I have 6 unshared electrons. So I have 6 unshared electrons plus half the shared electrons, which are 2 electrons. We will cancel this 2 with this 2. So I have here 1 plus 6 is equal to 7. 7. So 6 minus 7 is equal to minus 1. Minus 1 multiplied by the 2 is equal to minus 2. This is the minus 2 we usually write on the top of the sulfate ion.